All right, we're asked to expand these using the binomial formula or the Pascal's triangle. It's kind of an easy way of doing it. So I went ahead and I did two problems from the same learning set. This one has the choose idea in it. So we'll go ahead and just extend it out with the choose idea. And this one looks a little bit more of a normal format. So we got the 6th power here, and we got the 4th power here. So let's go ahead and build our Pascal's triangle. This is row 0, row 1, 1 plus 1 make 2 in the center, and we have the 1s on the end. 1s on the end, 1 plus 2 makes 3, 2 plus 1 makes 3, 1, 4, 3 plus 3 is 6, 3 plus 1 is 4, 1, 0, 1, 2, 3, 4, I need 2 more. That's a 5, 1 plus 4 is 5, 4 plus 6 is 10, 10, 5, 1, and it has that symmetry, so once you get to the halfway point, it's symmetrical on the other side. 1, 6, 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20. There's that symmetry, so it's a 15, a 6, and a 1. I'll go ahead and use another color so to denote which row. That's row 0, 1, 2, 3, 4, 5, and I needed row 6 for this one. I may have to erase some of this. I'll make sure I try to keep row 4 for that one and row 6 for this one since we're using the same concept there. All right, so then our formula is going to be, these are the constants for whatever the exponent is. So that exponent means we're in the 6th row here, and these are going to be the coefficients on each of kind of the powers. And let's go ahead and start to build that from here. All right, for me, I like going ahead and just building it off of these coefficients. So we'll go from there. The form is a plus b to the n. I always like kind of writing it underneath so we can see what b is, we can see what a is, and there's our n, which matches to the 6th row of the Pascal's triangle. All right, so a is m, b is that one choose m idea. Okay, so these are our coefficients. So our a is m, and the power is going to always add up to be 6. The powers have to add up to be 6. So this first one is just 6. There's no b part or the choose part here. And the coefficient, I like writing it when we first start these, the coefficient's 1. So it links together. And I'll show you my technique as we develop it more. Plus, and then it's a is m to the 5th. It always goes down by 1 exponent. And then we start on the other one. The b in this case is 1 choose m. And usually the choose has those parentheses around it. What am I forgetting? The coefficient. It's the whole point of this. Plus 6 right there. And I like having the exponents just to keep our place. The next one, plus, I'll write the coefficient this time first. 15 m to the 6, 5, 4, and then this one starts to go up. 1 choose m, and we're squared on that one. So that's the 15. The 20 is a plus 20 here. M to the 3rd on that one. And then our choose is now a 3rd also. So we're in the middle. Those kind of have that symmetry, that balance. And on the next one, plus, we got a 6, 15, 20, that 15. M squared, 1 choose m, is now a 4th. Notice that 4 plus 2 makes 6. Plus 6, m to the 1st. Definitely okay having that. And our choose part is 1 choose m. And we're now at the 5th. And then the last one, there's 6 and there's 1. We just want to make sure everything links together. These link always. Plus the 1, m to the 0. M to the 0. I don't need that. 1. Anything to the 0 is always uno, 1. So I'm going to let that one go. 1 times 1. Multiplication identity. Don't need it. And 1, choose m. We're now at the 6th power. And if there's any simplifying, I mean, we don't need these little 1s floating around. With these choose ideas, choose to an exponent, the exponents kind of get applied to everything inside the choose. So we could do that. Let's see, I ran out of room here. And I'll go ahead and take over this spot right here just to finish it off. So basically, we're just distributing the exponents on the choose. And I'm going to go ahead and let go of all the coefficients that we don't need and all the exponents we don't need. All right, so this now turns into, we're going to wait on that guy for now. This turns into m to the 6th plus 6m to the 5th. Choose 1, choose m. 1, choose m. So our choose, don't need that exponent. Plus 15, m to the 4th. This exponent basically distributes to both parts. 1 times 1 is 1, so we'll just say 1m squared plus, there's our 20, m cubed. The choose is 1 times 1 times 1 is 1, m to the 3rd. Check. 15m squared. The choose is to the 4th power. Plus 6. M to the 1st is just m. The choose, 1 choose m to the 5th is 1 times 1 times 1 times 1 times 1. And m times itself 5 times. And lastly, we don't need the coefficient of 1 in front. Plus, and when we distribute that 6 inside, 1 times itself 6 times is 1. M to the 6th. All right. Got it. Everything looks good on that one. And it should have that symmetry, so there's our 6's right there. 6m, 5 and 1, 15, the 2 and the 4, and then the 20 right in center, 3 and 3. Yes, we're good. All right. I'll go ahead and let this go. We need the 4th one on that one, so I'll go ahead and let this out of the way. All right. And so now we're focused on this. I'll go ahead, since I already wrote the answer down. Okay. We'll do it the same way. I'll write underneath it the general form. That way things match a little bit easier. This is our a plus b, and there's our n. Our n is 4, our b is negative t, and our a in this case is r. This is our 4th level of Pascal's triangle. So I'll do it underneath it this time. So our first level is our coefficients 1. A in this case is r. The exponent is the biggest one for it. The biggest one here is 4th power. And then I'll write it down, our negative t is the b part, and there's the 0. 4 plus 0 is 4, and anything to the 0 is 1, so basically I don't need that. I'll let it go when I simplify. Plus 4 is the next exponent. Sorry, coefficient. 4 is the next coefficient. And the a part is r, and we reduce by 1 exponent, so that turns into a 3 now. This negative t has the exponent goes up by 1. And our next coefficient is 6. R minus 1 from that is 2. Our b is now squared. Next coefficient is 4. 4r, I went from 2, now this one's at a 1. I'll just use placeholders right now to help keep track of everything. And our b is negative t. It went from squared, now it's cubed. And we're on the last coefficient, or last term. 1 is our coefficient, and then it's r to the 0. We subtract 1 from there. And negative t to the 4th. All right. Now we go ahead and simplify, and it's really important to kind of recognize that when we have negatives as a base for exponents, a even exponent is going to get rid of the negative because the negatives all pair up and make positives. But an odd exponent means the answer comes out as a negative. Okay, so I'm going to go ahead and just clean this all up. We have r to the 4th here. I don't need the coefficient of 1. Anything to the 0 is always 1, so that goes away also. We're left with r to the 4th. Plus 4, oh, I don't want that plus sign, do I? I don't want that plus sign. This is a negative right here. To the 1st power, that means this whole term turns negative. Negative 4 r cubed t. And try to keep alphabetic order when you write these out. It just makes it cleaner. Now it's a plus. 6r squared t squared. Negative t times negative t is t squared. And we're at this one. Plus. No, plus. Careful. There's that negative to an odd exponent. That turns everything negative. 4r to the 1st power is r, and then t times negative t times negative t is the negatives out front, and t cubed. Plus, and we don't need the 1 coefficient. R to the 0 is also 1. 1 times negative t to the 4th power. So that's an even exponent with the negative as a base. So t to the 4th. And that looks pretty good. One other thing I just kind of want to go into is the choose formula. Since it got brought up on this one, I'm really big on formulas. That makes it a little bit easier. So the choose formula, if I have n choose r, sometimes they have it as n choose r in that case. I like to think of it as whatever's on top is also in front. There's a few other notations, but I think those are the main ones. This turns into n factorial over, let's see, r factorial times n minus r, quantity factorial. Okay, so for these, this is our formula, so I just kind of plug them in the context that it's in. So if I just want to do a generalized example, let's do like 3 choose 2. So I have 3 people, and I'm sticking them in 2 car seats, 2 passenger seats. So this would be 3 factorial over 2 factorial times 3 minus 2 factorial. And there's some shortcuts here, but we'll go ahead and just extend it out. This is 3 times 2 times 1. That's what factorial means. You multiply all the descending order of numerals going down. 2 factorial is 2 times 1. And 3 minus 2 is 1 factorial. So this all turns into, and now I'm going to go ahead and simplify. it's all multiplied down here. So some things cancel. The 2's cancel here. 1 factorial is just 1 times 1. All of that turns into 3. So there's 3 different ways I can pick 2 units out of those 3. Okay.